When we come back again, so in this video we are going to practice more examples to totally master the formula we just introduced before. So as you can see, I copied the two formulas here, the one from the first method, the other one from the second. As you can see in this one we can just use a ratio times 2 pi r, and this one we set up the equation and use, since we have two fractions here, so we can use cross multiplication. So let's use the example I'm going to show you both with. Of course, you can just pause here to see if you can use a formula to by yourself, and later you can compare your answer with mine. But let's get started. So let's write down the method 1 and method 2 so we can just use a method here. So the first method is we are going to use arc mirror. Of course, since arc mirror is always same as central angle, so we can use either central angle or arc mirror here times 2 pi r. So in order to use a formula, we need to know what is a central angle or what's arc measurement and what is a radius. Let's check. In this question, we need to find arc AB. We already know, as you can see here, is our r, radius is 12, and the central angle here is 45 degrees. So we both have information. Let's just plug in here. Arc mirror, which is 45 degrees, same as central angle, over 360, and then times 2 pi, and also times 12. Remember 2 pi r, you don't see the operation sign here, which is actually the multiplication. So we can just stop here. What do we need to do? We need to put it in the calculator and find out the answer. One thing I want to share with you is when you put in the calculator, you can just put everything together. You don't need to break it down. So 45 divided by 360 and then times 2. For here, I want to remind everyone, do not use 3.14 unless the question told you to do so. So we are going to just put in the pi here, and a calculator will use a full decimal for the pi to do this. So how do we find pi? If you have a calculator, you know it's second, the arrow sign here. As you can see the screen, we have pi here. Last part, do not forget r times 12. And then we just go enter. So you can see we have a very long number here, right? So since the question didn't ask, we can just, let's see, most likely the question will tell you how to round it. So we can just put the answer as, so let's round it as nearest hundredths. So we keep the 2 decimal here. Since the third number is 4, the answer will be 9.42. So let's round it 9.42. And that's it. That's how do we find the arc length. Very straightforward, right? So now we are going to, let me change the color here. So we are going to introduce a second method. It's actually very similar. Again, really up to which method or what kind of a calculation you will use. But later I will show you one example where actually there does one method can be, better than the other one. So this one, we are going to set the ratios for two sides. The first side is arc mirror, which we already know that, again, same as central angle, so it's 45 over 360. And if you don't want to see, like you want to try on your own, again, you can always pause and I'll come back later to see how do I do that. So arc length is one we don't know for this case. So let's put it as x. So x is arc length. So over 2 pi, again, do we know the radius here? Which is we know, times 12. So you may wonder, hey, how do I solve it? So do not forget, since we have fractions on both sides, we can do cross multiplication. So this will be 360x equals to 25 times 2 pi times 12. Okay, so some students like to write down everything in the calculator and then find out the answer. It really doesn't matter. So for here, in order to solve x, we need to isolate, right? So I'm going to keep this right here. Keep the whole thing on top. I'm going to divide it by 360 because we need to solve it, cancel. We have to do the same thing in order to balance the equation. And now, since I have a whole thing, this is what I'm going to put in the calculator. So let's see how it looks. So I'm going to clear everything. It's easy to see that. So for this one is, we are going to type the whole thing on the top. If you want to put parentheses, that's fine. So make sure this is totally on the top. But since it's all multiplication, it really doesn't matter. So 45 times 2. Again, do not use 3.14. Instead, using 2 pi here times 12 divided by 360. Enter. Did you see? We have exactly the same number as we had before, right? So again, to the nearest hundreds will be 9.42, since the third number 4 is not greater than 5. So it's 9.42, sorry. So it's 9.42. As you can see, different method linked to exactly the same answer. Now we're going to practice another example to see we might need to deal with different method. Okay. For this one I'm going to only use the first method we introduced before, but if you want to use the second one and you do like the second one, you can always try that. Come back later, pause here, come back later to compare your answer with mine. So let's check the information. Information said the central angle given here is 100 degrees, and we need to find the length arc AMD. So if you notice that, it seems that the arc is actually exactly the opposite side of this. So if we want to use the formula, let's say length of AMD. If we want to use this one, we actually need this piece, right? So how do I find this central angle? Some students are figure out, oh, the whole circle is 360, right? So of course, so we use 360 minus 100. It is going to be 260. So that's going to be this piece. So now we have central angle, which is same as arc mirror. So we're going to just plug into this. Then do not forget we need 2 pieces. Central angle or arc mirror, same thing. And radius. Radius, of course, we label here, which is 18. So we can just plug in the answer. The value we have here, so 260. So again, always check which exactly central angle you do have, and you do need to more calculation. You need to do more calculation based on the information sometimes. Divided by 360, we find the ratio how central angle compared to the whole circle, and then times 2 pi times again, we put a radius here. So we don't need to do anything more. We just need to find the calculator, plug in, clear everything we had before. So 260 divide 360 times 2, again, do not use 3.14, use pi times 18, and then you can round it at the end. So this answer is 81.68. This time let's try to round it. Again, this question I didn't put it because I want to mention how do we round it for different cases, but most likely when we practice, we will be told how to, or what's the answer requirement. Round it to the nearest tens, nearest whole number, or nearest hundreds, thousands. It can be different. Let's say this one, I want to practice how to round it to the nearest tenth. Tens meaning this decimal here, right? 6. So in order to round to keep this number, we're going to check next number is 8. 5 or more, it's going to be raised up. So the answer, we can go 81.7, because again, let's go back to check this answer. 8 is greater than 5, rounded up 81.7. And that's it. So some student might say, hey, what is rounded to the nearest whole number? Then you can check it. What's the nearest whole number? I think you already figured out the answer, right? So 6 is greater than 5, rounded up, it's going to be 82. So really up to what's the answer requirement, how do we round it? One more example is going to be done. So next example, I actually going to show you, there will be cases we prefer the other method. Okay, so this one, let's read the question very carefully. The length of the arc is 5 pi inches. So very interesting. Some students probably already noticed, hey, This time we already know that this is 5 pi inches. We already know how long for that. Question is actually asking us, as you can see the picture, we know nothing about the radius. And the radius is the one we need to find. Find the length of the radius. So this case, if you want to try the first method, try on your own, and then come back to compare the answer with mine. But this time, since we need to find the radius, I think after the comparing, we think the second method is actually better to like working backwards. Instead of finding arc length, if we need to find a certain measurement like the radius or central angle, that will be something you want to try. So let's set up a ratio first. This one says arc mirror, meaning central angle, over 360, and the other side we just plug in the value. In order to use one here, first we need to find out what's arc mirror or central angle, which is already given, 30 over 360. The other side is arc length. In this case, as you can see, we already know arc length, which is 5 pi. So you may wonder, how do I plug in? We just plug in the whole thing, 5 pi. You can leave the unit at the end to plug in. And then we over 2 pi. Of course, we don't know the radius, so we are going to keep it r here. So that's something we need to look for. Check carefully. We have pi on the top, pi on the bottom, so we can cancel this, right? Now, let's focus on the left part. So let's rewrite it to make it clear. So it's 30, 360 equals 5 over, we don't have pi anymore, 2r. So we wonder, how do we do that? Of course, cross multiplication. So for one side, 30 times 2r. The other side, 360 times 5. So let's simplify a little bit. So 30 times 2, 60r. And this one we can just write down. If you want to do mental math, great. If you want to use calculator find it, that's also fine. So 0, 0 again, 3, and 1800. Okay, so you want to use, okay, you can always use calculator to double check if I'm right. So it's 360 times 5. So it's 1800, okay? So last step, we are going to divide by, in order to solve r, we need to do what? We need to isolate r. We have to do the same thing for both sides. Cancel 60, then r is what? R is 30. Again, if you want to double check, am I right? Or you want to do the calculation on your own. So it's going to be 1800 divided by 60 is 30. And do not forget, so for this one, we need to have, since original one question here, we have 5 pi inches, so this one will same as 30 inches. So again, not drawn to scale, even you look like the graph is not so big, but this is our answer. So just want a quick reminder, if we need to sometimes go back to sometimes cases, we don't know the central angle or we don't know the radius, but we do have arc length. I feel like this method is more easy, straightforward to find out this kind of measurement. Hopefully, you know, this practice are really helpful for you. You can always come back to check each examples. Hopefully you can, right now you have a pretty good understanding for the practice for this topic.